Oh, hey, I didn't see you there. Yeah, nice to meet you too. What's that? You want to hear about how I figured out what was inside of Black Box Circuit X? Well, sure, let me tell you. So, inside of Circuit X, we had four probe points, and in between those points, we could have a wire with no elements, a resistor, an inductor, a capacitor, or any combination of those elements in series or parallel. Now, a resistor maintains a linear relationship with voltage and current. Inductors and capacitors, it gets a little weird. A capacitor now tends to oppose changes in voltage across the 2 points, and there's some certain behaviors that'll give that away in our circuit. Inductors, on the other hand, they oppose changes in current, and those also have some unique behaviors that we'll be able to identify later. To start off, I began probing between the 4 points, looking for DC resistance just in ohms. And what I found was that points 2 and 4 appeared to be shorted, points 1 and 3 appeared to be overloaded, and between points 3 and 4 we had 35 and change ohms resistance. And now, what that would suggest is a couple of things. So between points 2 and 4, although it appeared to be no resistance, there could be an inductor there. That's just the nature of the behavior of an inductor at low frequency. And between points 1 and 3, while you could assume that it's an open circuit because it's infinite resistance, it could also be a capacitor there. And at low frequencies, capacitors have very high impedance and do appear to be open circuits if you were just probing for resistance. Points 3 and 4, on the other hand, are a little more interesting. We know for sure that there's at least 35 ohms of resistance between those 2 points, but there could be a capacitor in parallel, there could be an inductor in series. There were a lot of possible combinations that through testing we would have to determine. So moving on from the DC resistance test, I went on to a frequency analysis. I chose a pretty modest frequency of about 5 kilohertz just to see if I could get any current flowing through points 1 and 3 to see if it really was truly open or if there was a capacitor hiding in there. So I started with a sine wave, and the behavior I noticed was consistent with that of a capacitor. At 5 kilohertz, I did have current flowing through, and also current was leading the voltage, and that is characteristic of a capacitor. Next, to determine if it was just a single capacitor or if there was potentially an additional inductor between points 1 and 3, I applied a square wave to simulate toggling a switch. And what I saw was pretty interesting. So regardless of the frequency applied, there was no overshoot, and that is consistent with what you would find if it was just a single capacitor between those 2 points. Applying a sine wave between points 3 and 4 gave me some pretty unique results. Remember, at this point, I'm thinking it could either be an inductor in series with a resistor or a capacitor in parallel with a resistor. Now, across the entire frequency spectrum, the voltage and current remained in phase the entire time. They had a difference of amplitude that was proportional to that 35 ohm resistance. So that, along with the fact that there was no overshoot and there were no other indications of a capacitor or an inductor, led me to believe that there was just a single series resistance between probe points 3 and 4. Now, getting back to the capacitor that I believe was between points 1 and 3, I had to apply a pretty specific method to determine what that capacitance was. So I applied a square wave that was going to simulate flipping a switch, in essence, between points 1 and 3, along with a small known series resistance. And what that allowed me to do was to calculate the RC time constant. And from that, it was pretty trivial to calculate the capacitance. I measured the peak of the waveform after it had reached that equilibrium with the square wave. And I knew that one time constant equals 63.2% of that rise in voltage. So just simply using the measurement tools on the oscilloscope and some simple algebra, I was able to determine that the capacitor had a value of 193 microfarad. So to recount, I started from measuring DC ohmic resistance between all the combinations of points. I found out that the bottom two probe points appeared to be shorted, the top two appeared to be open, and between probe points 1 and 3, I saw a 35 ohm resistance. I used a function generator in conjunction with an oscilloscope to apply varying frequency sine and square waves between all the points to determine the possible combinations of elements inside. I believe that circuit 10 contains a 193 microfarad capacitor between points 1 and 3 and a single 35 ohm resistor between points 3 and 4.